The next step in machine learning is training the testing set and hyperparameter tuning to improve the accuracy of our prediction. So in this tutorial, I am opening the Python file for energy, and the best machine learning model for energy is RIDGE, and best featureization scheme is Jarvis that we got from previous tutorial. So these are all hyperparameter tuning for all other properties that we are going to predict. So I am opening this. So again, if you are in Google Colab, you have to install composition based feature vector, and we will import this thing, and we will mount Google Drive, import the c2db underscore eng csv. This first 10 entries can be seen using this command, df.get command. These are the formula and energy values. Then we will rename the data frame heading so we can work with the composition based feature vector. The best visualization scheme is Jarvis, so we will put Jarvis here, and we will make the visualization. Then we will make a testing set by using train test split function. Then we will fit transform the testing set. Here I'm not running the fit transform on the validation set because we have already find the best model in the validation set. Now we are training the model on the testing set. So here RIDGE regressor is the best machine learning model for the prediction of energy. So model is equal to RIDGE. Don't think about alpha is equal to 40. This is the hyperparameter tuning I was talking about. For the time being, just remove the alpha equal to 14. Just run the default model. This is to save the model using Jobili package, Jobili Python package. So next time for prediction of the energy, we don't need to train the model again. We can just use the already trained the model that we have, and we will save that into this path. You can see it is in the 2d/save model folder. These are all the test models trained for the classical machine learning model, and these are for the neural network, which I will talk about in the next videos. So this is how we will determine the R-square value, mean absolute error, and root mean square error. Here R-square value is 0.9957. We will plot the best model is Jarvis with the RIDGE regressor with the R-square value 0.995756. So before saving the final model, we will run this is hyperparameter tuning using grid search CV. We will import that grid search CV method from the sklearn Python package. So these are the parameter. Here in the case of RIDGE regressor, there is only one parameter, which is alpha. We'll change the alpha value from 1 to 100, and we'll train the model multiple times, 100 times here in this case, and we'll find the best value of alpha that can produce good predictions. So here the alpha we got is 14. So we will go back and we'll put 14 there here. We'll put alpha is equal to 14 here and train the model again. And now we have trained them. We have to find the best model and best hyperparameter tuning on the testing set. We can say with the final model. For the final model, we can combine both the training set and testing set and train the model only on the training set using this command. We are not doing fit transform. See here we are using xtrain unscaled, which is not splitted into training set for the saving the model for the final model, saving the final model. So we are fitting the xtrain unscale. Then we are training the model in the xtrain unscaled value and ytrain. Then we will save the final model into save underscore model folder. So for the next time, if you want to make prediction, you can load the model using load command instead of training the model again, which will take some time. So these are the results of classical model performance on the testing set after hyperparameter tuning. These are the properties which we are predicting and the best featureization scheme. Almost all the time it is aligning, and the best model is extra-tree regressor almost all the time. And these are the hyperparameters. For example, we have done energy, which was only one hyperparameter, alpha, which is equal to 14. For other like for extra-tree regressor, we have other hyperparameters like minimum sample leaf, which is 1, minimum sample split 2, and estimator 350. So for different material properties, according to the data, the hyperparameters will be different. And the ridge regressor, only one hyperparameter we are modifying, which is alpha. For extra-tree regressor and gradient boost regressor, here these are the hyperparameters we are changing in using grid search CV. So here I am showing the prediction of 2D plasma frequency x direction on the testing set after hyperparameter tuning. The best model is extra-tree regressor and the best featureization scheme is Olining. These are the hyperparameters that we are changing. Here minimum sample leaf 1, 2, 3 we are trying. So minimum sample split like this, and estimators like static from 100 to 300 by interval, changing interval 50. So the more number of hyperparameters, the training time will also increase. Here for example, it will take like 3 times, 5 times, like multiplication level of increment is there. So for this case, these are the hyperparameters which perform better than the default values.